Now that you know a little bit about the reactive programming paradigm, which hopefully built upon what we had talked about in earlier parts of the course describing completable futures, and we've talked a little bit about the Java Flow API, which is the basis of Reactive Streams, let's talk about some of the popular implementations of the Reactive Streams API. In particular, we're going to talk about RxJava, and we're going to talk about Project Reactor. We will be focusing in this course on Project Reactor for reasons I'll talk about in a bit. Why do we care about implementations of the Reactive Streams API? Well, the reason for that is the Java Flow API isn't actually very useful by itself. There's a number of useless things. Here is a fork that has a chain for the handle. So it's not going to be very useful to eat stuff, right? Because you're going to pick up the fork and it'll just like kind of flop down. Likewise, if you had a key that didn't have an end that you could actually turn the lock with, it wouldn't be very useful. If you had a wine glass that every time you tried to drink it would dribble down your shirt, wouldn't be very helpful. And in the same spirit of useless things, the Java Flow API is not very useful. It's pretty useless. However, it provides the basis for interoperability between different reactive programming frameworks, such as Project Reactor, RxJava, and there's other ones as well, which we won't talk about. So it does provide a role, just not a very useful role in and of itself. Reactive Streams implementations like RxJava and Project Reactor enable the insertion of event transformer operators between source publishers and sync subscribers. So source publisher being the one that starts things off, sync subscriber being the one that finishes them off. And what you can do is you can have a bunch of operators that are inserted that are basically these things that are both processors, they're both publishers and subscribers. And you can use them to define a pipeline or an assembly line of transformer operators that will filter, merge, transform, whatever, the flow of events from the publishers to these subscribers. So that's what goes on in the middle. That's really where the secret sauce is for these Reactive Streams implementations, these frameworks. They give you literally hundreds of operators to apply to do stuff to the stream of data that goes whizzing by in the pipeline. Again, that should be somewhat intuitive to you now that you have a little experience programming with Java Streams. Very much the same kind of idea, just a few tweaks we'll talk about later. Much like Java Streams, you have this concept of kind of a pipes and filters like architecture, where you can have these filters that are connecting the pipes together, and then stuff can be transformed as it flows through there. This again should look very familiar to you from the work we've done with Java Streams. You get input, you have in Java Streams, they call them operations, and they have behaviors and they transform stuff. Very much the same kind of idea with Reactive Streams operators as opposed to operations. Just different names for more or less the same concept. It turns out in practice that you just about never use publisher, subscriber, and subscription, those interfaces we talked about before from the Flow API. You just about never use those things directly at all. But instead, you use various classes that implement those interfaces. And we're going to talk about some of those implementations here in a second. So it turns out that if you use RxJava, which is kind of one of the original implementations of Reactive Streams, started out actually using Java 6 of all strange things, before Java 8 was widely available. There's a bunch of interfaces and classes here: completable, maybe, single, observable, and flowable. In contrast, if you use Project Reactor, you only have two classes. You have mono and flux. And we're going to talk about all these things. So what is a mono? Well, a mono is very much like a completable future. It is an object that acts as a proxy, which either succeeds or fails, and may or may not emit a value, depending, of course, whether it succeeds or fails. And so it's very similar to an asynchronous optional, or very much like a completable future. In fact, the implementation that you're doing right now for your program assignment number 3, where we're doing the completable futures variant of this, the completable futures could almost be replaced one-to-one with monos, and you'd get almost exactly the same implementation. And here's a very simple example. We're going to have a reduced fraction, which we're going to convert into a mono, and then we're going to convert that reduced fraction to a mixed string, and then we're going to go ahead and print the result. So this looks a little bit like a stream, a little bit like a completable future, and we'll talk more about how it works later. What is a flux? Well, a flux is another emitter, like a mono, but the difference is it can emit an indefinite number, or an infinite number, if you will, of events. And it can have 0 events, it can have 1 event, it can have 100 events, it can have an infinite number of events, and it will optionally complete successfully or with failure. And one of the things that a flux can do that's really cool is it supports back pressure, which means that the publisher source can be instructed to slow down or not send data until the subscriber sync or syncs can keep up with the flow of the data. So it keeps fast publishers from overwhelming the resources of slower subscribers that have lots of work to do. And here's a very simple example of a flux where we're going to go ahead and essentially create or emit a bunch of longs in the range from 1 to count. And we're going to emit them, and we're going to call some supplier on each of those events. And then we're going to go ahead and complete when we're done. And we'll talk again about this. We can have up to n of these things emitted. RxJava has a lot more classes. It has something called a single, which is very similar to a mono, which will either complete successfully or basically emit either one item or it will fail. And here's a very simple example where we're going to emit some call that we make, and we're going to subscribe this to run in the background thread, and we're going to go ahead and print the results of in the background. You can have something called an observable, which is very much like a flux in that it can emit an indefinite number of events from 0 to an infinite number, optionally returning success or failure. Unlike flux, however, observable does not support back pressure. So it'll just send events as quickly as it can, which could be a problem. And here's a simple example where we're going to emit a bunch of numbers from 1 to s max fractions, and then we're going to go ahead and subscribe, and we're going to basically print out a random big fraction. And if it all goes well, we're going to have a complete operation when we're finished. If we fail, we're also going to complete. And there's something called a flowable. A flowable is basically an observable that supports back pressure, so it's essentially like a flux. And in this particular case, this is a real fun example. We're going to emit a string, and then in parallel, we're going to do a bunch of processing to do some exchange rate queries, and then we're going to merge the results back together again and only emit something if it happens before 2 seconds elapse. So you can do really powerful things with flowables in cool ways. There's also this other thing called a completable and a maybe. I'm not going to talk about them right now. In fact, I probably won't talk about them much at all because we're not going to cover RxJava in detail, but I may make passing references to them when we talk about Project Reactor, just so you'll know what the RxJava equivalents are of certain features. Okay, so that's a quick overview of some of the key classes. We are just going to focus largely on mono and fluxes, and you'll get a chance to program them with assignment number 4, which is really going to be very fun.